So the Regulatory Reform Fire Safety Order 2005 and its implication for fire doors. So Lorient, we are a very proud UK manufacturer and we're based in Newton Abbot in Devon, and we've built a very strong reputation for designing and manufacturing high performance door sealing systems. And our seals enhance a building's performance, whether they're containing sound within a room or preventing it from entering, restricting the movement of fire and smoke. And this indeed helps actually improve the building's energy efficiency by keeping in the heat. So today we are going to look at the casualties from fire and smoke, the nature and behaviour of smoke, door assemblies for fire and smoke containment, the regulations, the importance of fire testing and the effective design of sealing systems, the need for independent accreditation, looking at a few fire door examples, some cost-effective solutions before reaching the right conclusion. So starting off with the statistics. Now, these are the latest government statistics for fire in England, and deaths and injuries is actually falling, but it's still a very unacceptable figure. The fact that we've lost the life of over 240 people and nearly 7,000 people being injured. Property losses is a figure actually collected by the Association of British Insurers, and when fires are happening now, they're happening on a much bigger scale. So I'm confident that that figure is actually going to increase. But when we look at the detailed analysis of the deaths and injuries, 54% of the people have actually died from smoke. People think in the event of a fire you're going to be burnt to death, and you will, but it will be the smoke that knocks you out first. And so that fire door is a really important part of actually the passive fire protection of any building. It's a piece of fire safety engineering, and it's specified, designed and burnt to destruction primarily to protect lives and then save property. And it plays a vital part in combating the unacceptable statistics that we've just seen. It's got to function as a normal door in everyday life, but then when a fire breaks out, it's got to be the effective barrier to prevent the spread of it. Now, we've got to be able to evacuate a building safely, and that might be horizontally or vertically. And fire and rescue have got to be able to come into the building because there may be some occupants left inside. And that fire resistance is always defined in minutes, 30, 60, 90 or 120 minutes from a timber fire door. And if we're looking at something like 4 hours, then we will be moving to a metal door. And so what we want to do is limit the size and the spread of that fire to the room of origin. We do not want it traveling out of that compartment. Now, when you've got that combustion process taking place in that room of origin, the pressure is absolutely phenomenal. That smoke is going to be forced to the ceiling when then it's going to spread sideways. It's going to travel through the head of the door and it's going to travel down a corridor. Now, generally, that smoke will always outrun the fire. As it then travels away from the seat of the fire, it will begin to lose its buoyancy and it will then drop and it will creep and it will travel through the smallest of gaps, particularly the threshold. The smoke temperature in the room of origin is going to be 600 degrees C and the temperature in the fire compartment is going to be 25 degrees C. Now, we classify it as cold smoke, but it's highly toxic and it will burn your skin. And the reason for the statistics that we looked at earlier is because of this lethal gas called carbon monoxide. We cannot see it, smell it, or taste it. Now, we need oxygen to breathe in our normal atmosphere, and when that drops to levels as low as 14%, and we introduce just 1% of carbon monoxide, it could lead to disorientation in 20 seconds, unconscious in 60 seconds, with death then soon after. Now, everything does depend on the size and degree of ventilation in the room that this takes place. But people think that you are going to wake up because of the irritation of smoke. However, this gas, carbon monoxide, is absorbed through your skin, taken by the blood straight to the brain. And that is why you become giddy and fall over. And it's also why the smoke knocks you out and then the fire cooks you. Now, I know that this is a very sobering thought and it's not a good message to actually deliver at any time of the day, but that is why we've got to talk about fire doors and their purpose. Now, this is the fire side of a set of doors and a screen that was installed in a Dorset school. The fire actually happened over the Christmas holidays in 2012, and it was actually thought to have started by a lightning strike. And the plume of this fire was actually seen for miles around, and it took 70 brave firefighters from 4 different counties over 24 hours to actually deal with it. Now you can see obviously the massive scorching and burning that has taken place here, all the debris on the floor and the ceiling, but those doors and that screen are still standing. The white material that you can see in the screen, either side of those fire doors, is actually the intumescent that was in the glass. And we're obviously very clearly on the fire side. But this, however, is the non-fire side. The fire doors look absolutely fantastic. They're still standing in their frame, vertical. They haven't bowed or twisted. We can see that some oil has trickled from the door closer on the left-hand leaf, that the arms are drooping. However, everything is intact. It is still standing there. And the great thing is with this particular image, again, is the fact that the wicker man is still standing there. There was no radiated heat to cause him to combust. And so the doors did exactly as they were designed to do. And of course, they didn't know when they were going to be needed. I have to say, by the way, there was nobody at school and nobody got hurt. And so I'd just like to also share with you some images of real life buildings. Bristol City Council had a fire, as you can see here in the top flat. Again, we can see the fire and smoke damage out of the windows. And this is the front door that had to basically be bashed down because the occupant wouldn't actually let fire and rescue have access to the flat. And that was the room of origin. Again, you could see from the state of the front door that even though it got bashed in, that fire was contained into that one flat. It didn't spread to the corridor, the escape corridor. It didn't affect anybody else. Everybody was all right. Now, there are 3 approved documents that may affect that fire door depending on where it's located. And although the Regulatory Reform Fire Safety Order isn't retrospective in the sense of we could be looking at fire doors in terms of inspecting and maintaining them today that were installed 20, 30, 50 years ago even. However, I've got to draw your attention to what the current approved documents say. Now, approved document B is obviously for protection against fire and smoke at all temperatures. The fire door may also have to have a sound capability under approved document E. And a scenario where you might encounter this would be, for example, a flat entrance door, a school classroom door, a hotel bedroom door. They have got to have fire, smoke and sound. And from a seal point of view, that means that we're putting on seals on the 2 long edges and the head of a fire door under ADB. It's a recommendation that we seal the threshold for cold smoke. However, when we're dealing with approved document E, if you do not have seals on all 4 sides, you will not get the designed capability of fire, smoke and sound. However, approved document M ensures the ease of access for everybody in and around buildings. And the minute that we're dealing with a fire and smoke door that also has sound capability and we're putting seals on all 4 sides, we may get friction. And we have got to make sure that the door closer that shuts the door into the frame latches shut every single time to give us that designed performance. So we've got to minimize friction at all costs. So the current approved document B that was amended very recently stresses in Appendix C that when we're actually looking at the fire door, that we have got to make sure that it demonstrates compliance, is applicable to the complete installed assembly, drawing attention to the fact that small differences in detail may affect the rating. And so that can be something as small as the fact that the fire door has got no test evidence for a door viewer, and yet somebody has put a door viewer in that door. It's a very complex system. Fire doors are tested and literally burnt to destruction to prove that they work. So we've got to make sure that everything is as tested. Now, Regulation 38 is the link between the approved document B and the Regulatory Reform Fire Safety Order. And this very clearly states that the fire safety information must be given to the responsible person, either when the project is completed or when the building becomes occupied. And this is so that that person defined as the person responsible has got the information to be able to implement the fire safety strategy of that building, maintain any fire safety system in it, and carry out a fire risk assessment. I know that I'm talking about a lot of regulations, but all of these are key because we're dealing with a life-saving product. Regulation 7 says that building work carried out with adequate proper materials must be appropriate for the circumstances in which they're used. So this is relying on the fact that somebody is going to purchase and install, if the components are being brought separately together to make the fire door, are doing it correctly, that they have the knowledge of what they're doing. And so the Regulatory Reform Fire Safety Order actually collated, it deleted and amended over 118 pieces of different legislation. Although this is dated 2005, it actually became effective in 2006. The government at the time said that the introduction would not become a consultant's charter or place an undue burden on businesses. And the Regulatory Reform Fire Safety Order applies to any workplace, common areas within apartment blocks, but does not affect domestic premises. So it does not affect our domestic house, but it affects all different kinds of public buildings outside our domestic house. So even, for example, places that you might not consider, for example, like a church. And so moving on directly to the Regulatory Reform Fire Safety Order, it demands that fire precautions are put in place that are reasonable and practicable, and they are to protect relevant persons. And so relevant persons, they could be the people that work within the building, they could be the visitors. It affects everybody that comes into that building. And staying within the law, it determines that duties imposed upon the responsible person who have control are to make a suitable and sufficient assessment of the risks, and they can nominate a competent person to implement those risks. Essentially, if you are managing or maintaining or installing fire safety components, such as fire doors, then you are almost certainly either the defined responsible person or a competent person, or both. Now, the responsible person can never escape their duty, and they've got to comply with the requirements of the order. Again, Article 17 within the Regulatory Reform Fire Safety Order says that we have got to ensure that premises and any facilities or equipment or devices are subject to a suitable system of maintenance and are maintained in an efficient state and in a good working order and good repair. Now, this includes, obviously, fire door maintenance. It also includes other elements that I'm not involved in. For example, fire alarm maintenance, extinguisher maintenance. But as I say, this will be defined as either a facility or an equipment device. Now, what are the consequences if, for example, you do not have a proper risk assessment? And we've got to remember that fire and rescue not only put the fires out as a consequence of equipment and devices failing, but they're also the people that are the enforcers. Now, the very fact that you may have had a fire, for example, and not injured anybody, this will not save you from risk of prosecution or a significant fine. I believe that the test in court would be, have you actually managed it? Have you managed the risk of a potential fire? Now, in terms of action, fire and rescue want to work with building owners and occupiers. And so they may give informal advice initially when they come in and they see a problem. And it may just be something like an alteration notice. They will give you an acceptable time, I believe, to undertake this necessary work. However, if you do not comply with their informal request and advice, then it may go down a formal route. It may be an alteration notice, prohibition, and the minute that we're getting to, for example, a prohibition, they may restrict what you can do with that particular building. And what we don't want is obviously prosecution. And this is on the basis that nothing has happened, in the sense of nobody has died. This is just them coming in to check your risk assessment. This is some high-level prosecutions that were enforced by court action. Now, the obvious thing with fire doors failing when they're needed, and of course they never know when they're needed because they're part of the passive fire protection. They sit there functioning as a normal door, and then when a fire breaks out, there's an expectation from all of us that they will work. And tragically, 6 people died at Lacanau House and 3 people died at Penhallow. And we certainly don't want that. Now, moving on very quickly, how do we actually know that those fire doors are going to work? Well, the only way that anybody knows that they're going to work is that we have to test them, and we literally burn them to destruction. So we go to UCAS test stations, we have a choice of tests, the original British standard 476 test or the European test 1634, full-size door, complete with its ironmongery frame, intumescent seals. If we want a vision panel in them, I know that we're looking at 2-paneled doors here, then they will have vision panels in them, but we burn them to destruction and we have got to do our time. Now, if you do not do your time, so you're doing an FD30 test, you only get 29 minutes, 50 seconds, it is a failure. Something as obvious as the flames breaking out as we have here on the right, or it could be something as simple as a little cotton pad the size of a piece of toast being waved across the face of the door. If that ignites from radiated heat, it's a failure. Now I'm going to show you how quickly things can go wrong if somebody forgets to give their door and vision panel some intumescent seals. This is a very short video.
We're going to show you a test sequence made by BBC South West for Inside Out after the tragic hotel fire at Penhallow in Cornwall. Samantha Smith is the presenter.
This test shows how getting fire safety wrong can be catastrophic. The door on the right is correctly fitted with flame and smoke seals around the frame and window. The one on the left, identical in every other way, has no seals. A fire door should hold back a blaze for half an hour.
Alan, must be about 13 minutes in now. The door on the right is intact. The door on the left is starting to burn through.
Yes, what you have to remember is that these are both fire doors. Only the door on the right has fire seals and smoke seals.
Look, it's actually going now. Look at that.
And that's a new door. Many of the ones that we've looked at in hotels are old doors. They don't fit very well. They're damaged. They've not been maintained. And if a new door will fail in 15 minutes, an old door will probably go a lot quicker than that.
So if we were in a hotel right now, the fire would have breached through that door, be travelling along the next corridor into the next compartment of the hotel. If the right-hand door was fitted, we'd be safe.
Yes, you would be, yes.
That's a graphic example of the value of properly specified and fitted fire doors. It was 25 minutes after the first door failed that the sealed door finally gave way.
And that is what the fire door manufacturers and the component manufacturers want. Safety is defined in minutes, and nobody just wants to get over the line of 30 minutes, 10 seconds. Everybody wants extra minutes. Safety is defined always in minutes when we're dealing with fire doors. Now, I would like to just very quickly show you the locations of intumescent seals, because this is the material, as you saw from my short video just now, that makes the fire door work. The fire seal is entirely dependent on the door manufacturer's core, and they are equally reliant upon the fire seal working. Now, it will either be located in the frame or the leaf, and that location is determined by the fire door manufacturer. You can see here in my image on the left that I've got a combined fire and smoke seal fitted into the frame. Now, that material, when it's subjected to heat, expands and it fills the 2 long edges and the head of the door. The intumescent seal expands at roughly 5 to 10 times the original size of the seal before it got exposed to the heat. Now, it's the material that holds the door into the frame to give you that safe compartment Now, I'm showing it in the image A with fins, and whether that's a fin or a brush, that then means that we've got cold smoke protection, and that fin or that brush must touch the opposing leaf. So if it's positioned as it's seen here in the frame, that fin or brush has got to touch the door edge. And equally, if it's in the leaf, it has got to touch the edge of the door frame. And the tolerances of this are very fine. The tested gap for a fire door on the two long edges and the head of the door is 2 to 4 mil. And when we're dealing with a combined fire and smoke seal, and we know that smoke is the killer, that gap is 3 mil, and we're given a 1 mil tolerance, so it becomes 3 to 4 mil to allow that door to open and close. Because we've got to remember friction. We've got to remember that people have to get through these doors. But intermittent seals, which get sometimes called intermittent, but I promise you they're intermittent, are seals which contain different materials. The material that you can see here on the screen, the white material, is called sodium silicate. It's a chemical formula and it expands every single time at 120 degrees C. But the material that's most common is what we call graphite. It's a grey material and it's got a different formulation from different manufacturers, and that can expand at anything from 170 to 300 degrees C. And what we cannot do in the perimeter of the fire door is mix and match sodium silicate with graphite seals. Now they can go in different locations, but on the two long edges and the head of the door or on the meeting styles of pears, we cannot mix and match the materials or the brand. And the reason for that is that if it's mixed and matched, the first thing that happens is you invalidate the test evidence of the fire door manufacturer. Now, he may have test evidence with both materials, but we were never mixed in the perimeter of the fire door when it went into the furnace and undertook the fire test. And the second thing, which is more serious, because this will only become apparent, and there might, for example, be loss of life. Mixing and matching the materials mean that we know sodium silicate will go off first, it will expand first, and it will be trying to hold the leaf into the frame. But the graphite needs a higher temperature, and so that is when we may get an integrity failure. And it could be seconds, it could be minutes, but we can't take that risk. So please do not mix and match intermittent seals. And as I say, the size and location of those seals is always determined by the test evidence of the door manufacturer. And when the door manufacturers go to test, they test their doors as singles and pairs, single acting, double acting. And what we cannot do is ever make two single leaves into a double leaf. If we want a pair of doors, whether they're single swing or double swing, they have got to have been tested as a pair. We cannot simply, if we're not taking in a door set, go to a door store, whether that's builders, merchants and places in the country. I shouldn't name anybody. But what we can't do is go out and buy off the shelf and make two singles into a pair of doors. Well, all doors are hard to get through, but pairs of doors are really, really difficult. So many things can happen. And so how do we actually recognize a fire door? Well, the third-party accredited schemes that I'm going to show you now have been around for about 25 years now. You may have doors in buildings that are older than this that may or may not have any markings, but this is the common way to mark and identify fire doors now. If the doors have come through the BM Trada scheme, then they will have a plug. Now, these plugs are quite small, the end of a pencil. They tend to get positioned in a fire door on the hinge side of the door, generally between the middle and top hinge, so they are visible when the door is open. They're coloured plugs with inner coloured fir trees, and across those fir trees, you will find a Q number. That Q number identifies the original manufacturer of that door or door set. The inner colour fir tree determines how that door left that door manufacturer. The alternative way, or a very common way of recognising fire doors, are doors that have come through the BWF certifier scheme. Now, they have a label that sits on the head of the door, and it very clearly tells us that it's an FD30 or 60, for example. It could be a 90 or 120 minutes, by the way. It has a certifier number. So the CF996 that you can see on the screen is the individual test evidence applicable to that particular, for example, FD30. Clearly tells you who the door manufacturer is and how you can contact them. So if you're in any doubt about what you're looking at the door, you can either refer back through a plug or you can do it through a certified certificate and a label. Everything with regard to the Regulatory Reform Fire Safety Order, and particularly fire doors, comes down to test evidence. Whatever we're looking at in terms of the door, what are we inspecting, what are we maintaining, comes back to how did that door get through its test. And so you may have a test report that you're referring to, or you may have a global assessment, or you might have a certified certificate, but the detail will be in the paperwork trail. And if we go back to the beginning, ADB says that this kind of information must be handed over to ensure that that responsible person can carry out that risk assessment. It's also essential for anybody installing the door, inspecting the door, and critically maintaining it. Now, before I move on and show you some examples of issues at fire doors, I'd just like to point out the areas that we might be inspecting and maintaining. And so what we have here is an example of a pair of doors. They're single acting and we've got a screen. And so what we're looking at came in as a door set. Then the elements I'm going to tell you about should be fitted. If we're dealing with an assembly that has come into a building, then you just need to be mindful that these are the things that you should be looking for. And so dealing, for example, with vision panels and air transfer grills, those holes should only ever be put into a fire door, either by the original door manufacturer or what we call a license converter. And that is somebody that's been trained by the door manufacturer to put in correctly and consistently the holes or the apertures for these products. And with a glazing system for an aperture, again, that has to be done by those two people. But when we're dealing with that air transfer grill, the hole can be cut by the license converter or the door manufacturer. But the air transfer grill that's sitting at the bottom of that door, the square block, can actually be fitted by a contractor on site. When we're dealing now with ironmongery, hinges, concealed door closers, or locks or latches, because we've got two fire tests running parallel at the moment in the UK, 476 or 1634, those pieces of essential ironmongery might need additional intermescent protection. And so, for example, with the hinges, it might be that we need a material called monoammonium phosphate. It's a white material and it's a sheet material, and it will sit underneath each hinge blade. So that means it will be 1 mil of timber that needs to be taken out of either the leaf or the frame if we're reinstalling. This material doesn't expand, it actually insulates, and it therefore will not pop the size 8 screws out of the hinge blades. It simply makes sure that when the fire is attacking that door, that it doesn't cause that door to fail or drop. When we're dealing with a face fix closer, you will not need this material, but the minute a closer is sitting in the head of the door, that concealed door closer will need to be wrapped in this intermescent material. And the same thing with the lock. It may be that you need to wrap the lock case in 1 or 2 mil material. And again, you may need to do the forend and you may need to do the strike on the other side. And when we're dealing with the intermescent seals, obviously it's critical that the right seal is fitted in the right location. So this particular example that we are looking at here, on the meeting stile, we seem to have only one combined fire and smoke seal on the meeting stile, but the test evidence for the doors that you're inspecting may actually need a plain fire seal on the right-hand leaf. Nobody can ever say, without looking at the test evidence of a door, what is actually required. Is this monoammonium phosphate white sheet material needed or not? Everything will come back to how did the door get through that particular test. And so I just need to stress again, in terms of third-party accreditation, that it's a recommendation in approved document B that third-party accredited products and installers are used, but this is an entirely voluntary thing on the part of the manufacturers. But what it offers is protection and traceability. It ensures that the people, for example, inspecting doors and maintaining doors know exactly what they're doing. They are very clearly the competent people. As manufacturers like Lorient of life-saving products, we choose to have this third-party accreditation because it ensures that there's traceability back to us. We do not vary the way that we make any of our life-saving products. everything is to the tested detail. And it's not a one-off test. We get rigorously audited and have to retest our products. So look for third-party accredited products, look for third-party accredited installers and people that can maintain the doors that are third-party accredited, and critically, third-party inspectors. Let's make sure that when we're actually installing our doors that we do it correctly and once only. We're in Fire Door Safety Week, and Fire Door Safety Week has highlighted from the inspectors that the 3 top reasons for failing doors has been excessive gaps, poorly adjusted door closers, and issues around smoke sealing. 3 critical things that we have got to be aware of. If doors do not shut into their frame, they will not perform. If the gaps are too big, then smoke will travel straight through it. If the incorrect seal is fitted, the door will not work. Let's be mindful of what we're doing. And so let's look at some samples. And so here we've got missing seals. Now we know that the seals have got to be fitted on the 2 long edges in the head of a door. And we can clearly see that the leaf on the left-hand side has got an empty slot. That should have a combined fire and smoke seal. I cannot tell you without looking at the test evidence what it should be, but hopefully there's going to be something on the head of the door and the other jamb. So what we've got to do is then fit the tested seal. We don't need to make that slot any bigger, but we've got to make sure that we replace that gap. The image on the right, we clearly can see that that combined fire and smoke seal is a graphite seal. Above where we've got the missing strike, we've actually again got a gap where there should be another combined fire and smoke seal. 2 things need to be done here by competent people. That frame should be repaired by a third-party accredited maintenance person or company. And that could be somebody through LPCB or BM Trada. They're qualified to do that and make sure that it's a good repair. And the seal, we need to peel out, check whose brand it is, and make sure that we put the right seal back. If we peeled that seal out and we didn't know who the manufacturer was, then we've got to take the entire perimeter of the seal out on the rest of the frame and the head and put a brand new one back in. And that again is where third-party accredited products work best. Here we've got damaged seals. And so what we need to do here is peel them out and do exactly the same thing. If we cannot see the brand, we've got no test evidence to refer to, then we've got to choose another third-party accredited combined fire and smoke seal. And the seals, from a fire and smoke point of view, they could have fins, they could have brushes. Fins are kinder to allow the door to shut, but a brush is an excellent combined fire and smoke seal. Here we have got a grey combined fire and smoke seal brush that has been painted. And I need to highlight the fact that if you have got a painted brush or a painted fin, that will not give you the combined fire and smoke performance, but it's the smoke performance that's negated. The intumescent seal will still work, and so we have a choice here. We could leave that seal there and give it an independent, third-party accredited smoke seal. However, it may be better to peel that seal out and replace it, but you have to be mindful of when you do that, you've got to make sure that the intumescent seal fits completely flush into that old-fashioned slot. And a solution for an independent third-party accredited smoke seal could be something like batwing. Batwing sits in the corner of the door stop, as you can see in the image on the right. The door only comes into contact when it's in the shut position, and it gives you smoke and sound protection. However, there is no fire capability. And so that is why when that is fitted in a door that has no existing intumescent seal, it will always need a separate fire seal for that designed capability. I also need to reference a plain fire seal. If a plain fire seal is painted, the intumescent seal will still work, but please don't paint over with them when they are brand new. Now, damaged fire doors. I'm afraid that the way that the image was, or the photograph of this particular leaf was taken, it looks like it's got a narrower bottom than it has where we've got all the extensive damage. But this is a 44mm thick fire door, and you can see that trolleys have crashed in and damaged the door edge. One way of actually looking after this door without having to replace it at the moment is to fit something like a door edge protector. It will still require a seal, However, this is a solution to prevent that impact damage. This is fitted on the door edge, and the fixing is actually disguised underneath the intumescent seal. When it's fixed to the door, it comes in 44mm or 54mm thick width, and it comes in different lengths, so it'll suit alternative heights than a standard leaf. However, when that intumescent seal is then fitted, it disguises the fixings. Now, glazing, we've already touched on the fact that glazing should only be done by licensed converters and the original door manufacturer. However, if somebody puts their fist through a vision panel and we need to make an emergency repair, then obviously we have to do that because we may have sleeping people in those buildings. If you're going to carry out this kind of repair, please make sure that you actually have that door back in situ before you leave. So you can see in the top image that the Georgian wire glass was replaced and it's been put in. It looks like it's got some kind of silicone sealant to actually hold the glass into place. Now that is not a tested solution, and the bead detail hasn't been put back. So that really is a very, very bad repair. And we've got something similar going on in the image at the bottom. Now, here are two possible choices. And again, we're constantly having to refer back to test evidence, but two different glazing systems here. The one on the left is a graphite, and this is a 2-seal system. So we've got Georgian wire glass, and we need then the seal either side of it. We've got to obviously make sure then that when this repair is being done, the correct glazing system is used, the correct bead detail is used, and the correct fixings are used. There is absolutely no point going out and getting the glass and the seal if the tested detail of that bead is not followed. So please make sure that you follow the test evidence of the seal manufacturer. The one on the right, as you can see, is also a graphite material, but this is actually a channel. But again, the test detail is, how does that bead get fixed? What is the size and the degree of the chamfer? Please make sure that you follow the test evidence. Other reasons for potentially having holes in doors might be something like a letter plate. Two different letter plates here. They were actually flat entrance doors, and under the RRO, somebody recognised that they were not a fire and smoke solution in that fire door, so they were not going to protect the occupants if there was a fire or anybody fleeing down the corridor to escape a fire. And having heard that graphite works, you can see that with the top aperture, somebody went out and bought some graphite and lined it. Now that is not a tested solution. In the event of a fire, the flat that's being held up is going to melt, and that graphite will not swell enough to fill that hole. It is not a tested solution. And so a tested solution could be, for example, the letter plate here that is shown on the right. Because I'm not in front of you, I can't actually show you this, but it's actually a telescopic plate, and that white element is the graphite wrap. And what happens in the event of a fire, that graphite wrap completely crushes the PVC sleeve that goes in between the two elements. And so in the event of a fire, you will have a flat and a safe compartment and the safe means of escape. Air transfer grills. Just like a vision panel, they are potentially dangerous elements in a fire door. As we said earlier, the hole can be cut by the original door manufacturer or the licensed converter, and the air transfer grill can be put in by somebody on site. But the image that I'm showing you at the top is actually a beautiful handmade oak air transfer grill, but there is no fire or smoke capability in it. So in the event of a fire, the fire will simply whiz through those huge gaps there. The image that's at the bottom, that's got this wonderful metal cover grill, is also in a fire door. However, we can both see daylight on either side. And that is because somebody went to that door, recognized that the existing intumescent fire air transfer grill had actually become gummed up. I don't know what it was or whose it was. They took the cover grill off, took the block out, and then forgot to go back and replace it. And so again, that will simply not work. And so with regard to air transfer grills, the image here that we have as a solution, the image on the left, the LVN40, that is a fire-only system. So in the event of a fire, that will allow smoke to travel straight through it. So that can only go into a fire door. If we need to put an air transfer grill into a fire and smoke door, we're inspecting them and we need fresh air from one side of the door to the other, then we have got to fit a system like the one on the right. Now that is a system that's electromechanical. It's got 2 intermittent blocks, so that will give you the fire capability. And the shutter in the middle becomes the smoke shutter, so that will give you a protected escape route. It needs power, but power is taken to the door either through a conductor hinge or through a powered armoured cable. Quickly moving on to fire door signage, it has to be clear and precise. So the image at the top, that is an old-fashioned sign. It is not applicable to today. We need fire door keep shut or fire door keep locked signs on our fire doors. And the image at the bottom is a little bit confusing to those that may not know this building. I mean, we're being told that we're on the running green man, so we are on the escape route. However, I've got a confused message. It says that the door has to be kept locked and yet shut. That door should be fire door keep shut, not locked. Hinges. Hinges are essential to ensure that that door opens and closes freely. And so it needs all of its screws. We've got CE marked hinges at the top and yet 3 screws are missing. Please make sure if you are maintaining or installing that you give it all the screws that it needs. The hinge at the bottom looks like it's wearing. Now, we have a situation there that if we need to replace, if it's a CE marked hinge, we can put the identical hinge back. If we look at it and it isn't a CE marked hinge, then that's when we should be taking all of the hinges off and replacing them with one that is CE marked. And obviously the same size with regard to the hinge blade. We're not actually routing out any more from the leaf or the frame. Door closers are essential. They are the means, unless we actually have a floor spring, of ensuring that that door is shut into the frame every single time somebody passes through it and in the event of a fire. It may be that we're on a push and pull situation, there is no lock, in which case that door closer is even more important. And so it needs to be attached. The image at the top, that arm needs to be attached to its bracket. And the bottom one, I do not know how anybody goes through those doors with that closer swinging freely. Finally, the doors need to shut. The image at the top is obviously the fire and smoke door resting on the strike. It hasn't shut into its frame. Now that might be for a number of reasons. It might be that there's an issue with the door closer. It hasn't been properly adjusted to allow it to latch shut in the final few degrees. Or it could be that it's sitting on the seal. Either way, that door has got to latch into its frame to ensure that it works. The image at the bottom, a pair of fire and smoke doors, combined fire and smoke seal in the right-hand leaf, and yet again, they haven't shut. They should be completely flush. In the event of a fire, potentially both of those doors are going to be blown open, and then we may have a serious issue, loss of life and loss of a building. And so let us all remember, it doesn't matter how small the project or the works is, it's a principle of the building regulations that a person carrying out the work must not make the performance of the building any worse than it was before the work was carried out. Now, those are the sobering words from the coroner at Lacanau House many, many years ago. And yet, very sadly, we have had Grenville Tower. So please make sure that if you're involved in anything to do with fire doors, that you specify correctly, install correctly, use the right products, and ensure that they're maintained.